Hello everyone. In this class, we will introduce TANDIS. TANDIS is a transition device for the molten steel casting between the ladle and the mold, which is used to receive molten steel in the ladle and injection molten steel into the mold. The main functions of the TANDIS are reducing pressure, stabilizing flow, inclusion removal, separating flow, storing steel, and TANDIS metallurgy. Now let me introduce main parameters of TANDIS. First is TANDIS capacity. It means generally it is 20% to 40% of the ladle capacity. Second is TANDIS heat. The heat of TANDIS mainly depends on the depth requirement of the molten steel in the TANDIS. Generally, the depth of the molten steel in the TANDIS is 1600 to 1200 mm. The third is the TANDIS length. The length of TANDIS mainly depends on the distance between the TANDIS nodules. Next is TANDIS width. The TANDIS width can be determined according to the amount of the molten steel that should be stored in the TANDIS. Next is inner wall slope of TANDIS. It means generally the inner wall slope is 10% to 20%. The last one is TANDIS nodule diameter and nodule spacing. The structure and shape of the TANDIS should have the minimum heat dissipation area and good heat preservation performance. The commonly used section shapes of the TANDIS are circle, oval, triangle, rectangle, and T-shape. The shape of TANDIS should be simple to facilitate hoisting, storage, masonry, cleaning, and other operations. According to the number of nodules, it can be divided into single strain, multiple strain, etc. The number of the nodules of the TANDIS is generally 1 to 5. To the structure of TANDIS, we will introduce TANDIS shell and cover first. The shell is generally welded with 12 to 20 mm steel plate, and a number of holes are drilled to allow the refractories to breathe. The shell has a certain taper, an overflow slot at the upper mouth, an oblique angle at the lower edge, and reinforced rib welded on the body and bottom of the shell, and a hook on the cover and the shell. The TANDIS cover is used for heat and splash prevention, and also to reduce the radiative baking of the ladle bottom caused by the hot molten steel. It is also a steel plate welded structure lined with refractory concrete rim. There are holes for reheating on the cover, stopper holes, and a ladle casting hole in the middle. Next is the lining. The lining of TANDIS consists of working layer, permanent layer, and thermal insulation layer. The thermal insulation layer is made of asbestos board and thermal insulation brick, and the permanent layer is made of clay brick and cast as a whole. The working layer is in direct contact with the liquid steel, mainly made of high aluminum brick, magnesia brick, or thermal insulation plate. And the surface of the working layer is sprayed with 10 to 30 mm thick fire resistance mud to prove the protection effect. Next is slag wall. The large capacity TANDIS is also provided with slag wall or dam to isolate the disturbance of the ladle casting flow to the molten steel in the tendies, so that the flow of the molten steel in the tendies is more reasonable, which is more conducive to the floating of the non-metallic inclusions in the molten steel, so as to improve the purity. The next is stopper rod and nozzle. The control handle is connected with the sector gear, which drives the crossbeam and stopper core rod to move up and down through the rain rack and the lifting slide rod. The sliding gate controls the steel flow through the relative position between the sliding plates. Compared with stopper rod, it is safe and reliable, can accurately control the steel flow, and is conducive to automation. The Tyrant mainly adopts 3-layer sliding plate to control the steel flow. The sliding gate is mainly composed of up nozzle and sliding plate, low nozzle and sliding plate, and intermediate sliding plate. When working, the upper and the lower side plates are fixed, and the middle sliding plate is used to control the injection flow. Next is submerged entry nozzle. The submerged entry nozzle is located between the tendies and the mold. The upper end of the nozzle is connected with the tendies, and the lower end is injected into the mold still water. It insulates the contact between the casting floor and air, prevents the splashing caused by the impact of casting floor to the steel surface, and prevents the reoxidation. Through the selection of the nozzle shape, the flow state of molten steel in the mold can be adjusted to promote the selection of inclusions and improve the quality of the steel. According to the material, the submerged entry nozzle can be divided into 2 types: filled with silica submerged entry nozzle and aluminum carbon submerged entry nozzle. Fused silica submerged entry nozzle. The features of the nozzle are good thermal shock resistance, high mechanical strength and chemical stability, and acid resistance, slag erosion resistance. Do not need baking before use. This kind of nozzle is suitable for the casting general steel grades, not suitable for the casting steel grades with high manganese content. Aluminum carbon submerged entry nozzle. This kind of nozzle is mainly made of corundum and graphite. It is characterized by strong adaptability to steel grades, especially suitable for casting special steel and little pollution to molten steel. The material of the nozzle can also be adjusted according to the casting time and steel grade. Aluminum carbon submerged entry nozzle can only be used after baking, otherwise there is a risk of creaking. In addition, there is aluminum carbon submerged nozzle that can be used without baking. There are several requirements of submerged nozzle. First, it should withstand good thermal shock resistance. Second, it has good resistance to molten steel and slag erosion resistance. Third, it should withstand good mechanical strength and resistance to vibration. The fourth, submerged nozzle connection must be sealed unit. Fifth, it is not easy to react with molten steel to produce the plugs. At present, the most commonly used submerged nozzles are single-hole straight barrel type and double-side hole type, as shown in the figure. The straight hole type nozzle is generally used for square billet or small slabs. The side hole type nozzle is mainly used for square billets and slabs. A side hole inclination angle has three cans: upwards, downwards, or horizontal. Now, let me introduce the tennis car. The tennis car is used to support, transport, and replace the tennis equipment. The car structure should be conducive to casting, slack baling, oxygen burning, and other operations at the same time. It should also have the functions of traverse, lifting adjustment, and waving. Production process requires a tennis car can quickly replace tennis, accurately stop, and easily align the tennis nozzle on the mold. For the convenience of loading and unloading submerged nozzle, tennis should be able to lift. According to the location of tennis nozzle, main beam, and track, tennis car can be divided into two types: suspended type and gate type. This is two pictures for suspended type, which is suitable for inside section. The tennis car is composed of the frame, the running device, and adjusting mechanism essential, located on the body. The frame is a saddle frame welded by steel plate, which makes enough space around the submerged nozzle of tennis, so that the operator can observe, sample, add protective slack, and remove the residue of steel in the mold. The selection of the configuration scheme of the running mechanism of the tennis car should be based on no interference with the mold. Its running device mainly has three types: one-side driven, two-side centralized driven, and two-side separate driven. Adjusting mechanism plays a very important role in tennis car. The relative position of the mold and the nozzle of the tennis is adjusted by different mechanisms. In the direction perpendicular to the casting, the position of the nozzle is directly adjusted by running device. In the direction of the casting, the position of the nozzle is adjusted by the centering mechanism. At present, most of the centering mechanisms use screw and nut to achieve fine-tuning. In the direction of the heat, the position of the nozzle is adjusted by the lifting mechanism. In the use of submerged nozzle or low liquid level casting, the tennis should be able to rise and fall. Its lifting mechanism has electric screw and hydraulic transmission and other types. The key of the design is to ensure the synchronization of the lifting on both sides. In addition, the tennis car is also equipped with lower waving device to control the heat of the liquid steel level in the tennis. That's all for today. See you next time.